transmitter today. Just setting up the station. All right. So we're going to be drawing the circuit from scratch, and then we're going to be working on it. As you can see, we already started with the transistor. So we want to use an NPN transistor for this design. If you are new to transistors, please go to our channel and watch videos on basic electronics components. All right. So this is a symbol of a transistor. Making it look nicer. So this is the base, the emitter, and the collector. The emitter is the one that has the arrow. So, and then the other one is the collector. So here, we've drawn this circuit before, or similar circuit before. So this is going to be a capacitor 10 picofarads. At the emitter, you're going to have a resistor here. We're going to use a pot, variable resistor. Then this resistor, the wiper of the pot, potentiometer, is going to be the input for the video. So video input is going to go in here. So let's just finish this section now. So here you want to connect a diode, a signal diode. This signal diode is 1N4148. It's very common. And then here you want to add a capacitor. So this capacitor is 0.1 microfarads. Another value for this, if you want to use, well, not another value, but just another way of stating this 0.1 microfarad is 102. If you have those numbered capacitors, use this. I will show you how to calculate that, how to get this from this at the end. Then you just want to add a resistor here. And this resistor will be low resistance. It can be 75 ohms to 100 ohms. We're going to do 75 ohms. This is typical of the TV signal coming in so that you can match the impedance. So impedance matching, for impedance matching purposes, you want to have a capacitor here. Then the video goes in here. So there are two wires. One with the positive signal goes in here, and then the other one goes down here. The value of this capacitor, you can make it 470, standard 470 microfarads. And you can go from 25 volts. Anything that's bigger than the voltage of your supply voltage is good enough. This resistor here is going to be 1 kilo ohm. So I think we have all the videos. So this is the video input, V in, where V here is video input goes in here. Now let's bias this transistor. So we're going to have a voltage divider here. So here we're going to you're going to use 47 kilo here. And then down here also you're going to use 47 kilo. This is kind of 50% of the voltage input will be available here, right? So 47K, right? So this is your positive rail. Then let's build our frequency determining network here. So to do this, we're going to have a capacitor, variable capacitor. You can use from, let's say, 5 to say 45 picofarads. Something in that range would work, right? It doesn't have to be exact, right? It can be 30 picofarads, it can be 40 picofarads, but it's variable, right? So the reason for the range is to be able to change the frequency. And then in parallel with that, you have to have an inductor. So you can use 4 to 5 turns. But once you build it, you don't want to be changing it. The inductance of this inductor is going to be dependent on the thickness of the wire, the separation of the coil, the length of the magnetic circuit. So like if you finish the coil, Let me give you an example. See, this coil I have here has fixed number of turns. When you solder it in a circuit, it will have a particular inductance. However, if you squeeze it closer, the inductance will change. If you pull it apart, the inductance will also change. Even though you have the same number of turns, you have the same thickness, you're finished with this. But as you change it, the inductance will change. If you insert a magnetic material in it or around it, the inductance will also change. So it will become a variable inductor. You can also vary the circuit by doing that. Use variable can I control here, put a ferromagnetic material here as you adjust it, but it's easier if you're using a variable capacitor, right? So that one you can adjust, you can trim. Let me show you an example, because we won't be soldering this on camera. Let's find some good examples. So these are some variable capacitors. This one here is 30 picofarads, so we might be using it. If you have this green type, 30 picofarads. This one here is 50 picofarads. If you have the brown one, this here is 10 picofarads. So, and you have inductors here. You can use this kind of inductor, fixed inductor. You know the value of the inductor, so you don't have to make an inductor. If you know the value of the inductor, we can check the color code and find out the value. And we can also use our inductance meter to find the value. Maybe we'll do that once we find the value of the inductor. Let's do that now. Let's do that. And now we're saving the inductor for something else, but let's find out the value of this inductor. Or these inductors. So this one here is 5 microhenry. 5 microhenry inductor. Let's try the other one. This is 12 microhenry inductor. I just want to make sure, let me just calibrate this, make sure there's no I'm gonna shut this and calibrate it. All right, so here, sorry, I wasn't calibrating. I should zero it, not that. So inductor, and then I can zero it out. Calibration is okay. Let's do that again. Calibration is okay. Okay, zero, we've zeroed out, or we've dialed it if we're measuring weight. All right, so this is 8, and I'm gonna check the previous one we called 5. See if we get it right. Okay, it's 8. So we needed to tie it. We needed to calibrate it. So it's 8. Both of them are the same value. So we can use that 8 micro Henry, and then we just put it in a formula. Yeah, we put it in a formula to calculate the frequency. All right. So let's finish the design. Now we're gonna put another capacitor here. This goes to ground. The value of this capacitor is gonna be 0.001, and then I think we're almost done. Then we have to put our antenna here. Here we can use 27 picofarads for the antenna. We are almost there. Yeah, we need to put a bypass here to filter all the ripples. So this capacitor, we can use 220 microfarads. And for this one, we're going to use 0.1, same as this one here. So it also be 102. And this 0.001 is the same as 104. I think that's all we needed to use here. And then this is the TV transmitter. This will determine the frequency, and then the biasing of the transistor is achieved here. So this is built like an amplifier, but then this makes it an oscillator. You get a feedback to the emitter circuit. You modulate the circuit from the emitter circuit. So this resistor here is for temperature stability. However, you're going to be changing the value of the resistor by coupling a video signal to it. When you do that, you're going to affect the amplitude of the oscillator. The frequency will be fixed because of this, but the amplitude will be modulated because you're changing the gain of this transistor slightly, ever so slightly. You're changing the gain slightly, and so the amplitude will be like this on this other side of the envelope. So you'll be changing the gain, and because of that, it becomes amplitude modulated. You transmit your video through amplitude modulation. At the end, I'll show you this because we may not draw the circuit again. But at the end, we have to integrate the audio signal through here. We already built last week a circuit for this. We're going to put a resistor here. We'll find the best value, so the audio goes in here. Audio in. We're going to find the best value of this combination to make sure that it's not over modulated to reduce distortion. We'll play around with these values. Maybe we'll use a variable resistor here. Yeah, we can fix this value. We can say 0.001, and then we'll vary this to tune to get the right threshold. Or alternatively, we can use a port here. We can use a port here, and then have the video go in, the audio, sorry, go in here. So we can vary. Maybe we don't want to connect it this way. Let me give another option. The best option I'm thinking of right now is to go this way. This is ground, and then this one goes into this spot. That way you can vary the input signal from the highest to the lowest to ground. Let me not make it positive. Let's just call it A and B, between A and B, and then the audio signal will go in here. Obviously, the other circuit has a capacitor at the output, so that will go in here, and then so it's seeing constant load on the antenna, because that's going to be the antenna output of the previous circuit that we built last week. I'll show that on the screen. So this one here, so this wire, we're going to take it off and then link it to this resistor, so we can vary this value, right, until we get the best level for the TV transmitter. But let's solder up this section, and then we'll come and demo the full system working together. All right, so we're gonna build the TV transmitter. We'll test the TV transmitter, and then we make this modification, add these two components, and we'll test them together. So we'll be using the same board. We're going to make a room. I'm thinking to use a variable resistor like this. So this value, what is this value? The 100k, probably too much. So I'm going to find a different value. So we can use this here. They can vary and control the modulation, the audio modulation. We're probably going to need a second one for the video modulation, but this would then be too much for this small board. So let's see, we're probably going to use a pot. I'll show you the kind of pots we might use. We might use this kind of pots so that they're easier to fit on the board. We can have multiple. So we can use this one. So what's the value of this one here? This is 502, which is 5k. 502 is 5k. So we can use this and then just have it on the board. Yeah, we can easily have two of them. And the board can trim it to control the modulation, the audio modulation and the video modulation. So let's go into soldering. You won't be here watching us, but if you want to stay, maybe I'll end this broadcast and start a new one. So this one is not too long. If you want to be with us, it's going to be a long video because I have to source all the parts and then solder them. If you don't want to watch that, it's fine. So I'm gonna get started, but I'll end this broadcast first. All right, thanks for joining, and I'll see you when we're done with the soldering.